morning. Welcome back to Krishna online class. In today's session, we'll discuss about the hollow cylinder. Okay, what do you mean by hollow cylinder? Okay, yes. So first I'll draw the figure of this hollow cylinder. See here. Here a hollow cylinder means this is the exact shape of the hollow cylinder. Okay. See students, here hollow cylinder is nothing but this is one solid and which is empty from inside. Okay. And also which having some difference between its internal radius as well as external radius. Okay. So here you will be having two type of radius, that is internal radius and external radius. So what is this? What do you mean by internal radius and what do you mean by external radius? See here, this is the center. If I join this line, I mark it as O and I mark it as OA. Okay. So here OA is nothing but the radius. Okay. So this is known as internal radius. Okay. Internal radius. Okay. So internal radius is nothing but I'll represent this OA by small letter r. Okay. So that is nothing but OA. OA is nothing but a small letter r. Understood now? This OA represent internal radius. Okay. I'll represent it by small letter r. Okay. So again, so this is O dash. If I join this O dash with the outer region, I'll represent it by O dash B. Okay. So this O dash B is the bigger radius, isn't it? This is a larger than OA, isn't it? Okay. So what is this OB? O dash B. O dash B is known as external radius. Okay. O dash B is known as external radius. Okay. External radius. Okay. I will represent this external radius by capital letter R. Okay. Capital letter R. Okay. So you can observe here external radius is larger than the internal radius. Okay. OA means internal radius. O dash B means external radius. Okay. The length of the external radius is larger than the internal radius. Okay. So here some difference you can observe in between the internal radius and the external radius. Okay. Yes. So then what about CSA, TSA and volume of the hollow cylinder? Students, you have studied about the CSA, TSA and volume of the cylinder. Isn't it? Cylinder means a right circular cylinder in your previous session. But the hollow cylinder, for the hollow cylinder, the CSA, TSA and volume will be different. Okay. So then what is the formula? I'll write down the formula. Okay. CSA, TSA and volume. Okay. So first we will see about this CSA. Okay. What is the CSA of this hollow cylinder? Okay. So its CSA is given by 2 pi h into r plus r. Okay. 2 pi h into small letter r means internal radius plus capital letter R means external radius. Okay. Next, TSA. What is the formula for TSA? Its TSA is given by 2 pi into R plus R into H plus R minus R. Okay. So this is the formula to calculate TSA. Okay. What is the TSA formula? 2 pi into R plus R into H plus R minus R. This is the formula for TSA of the hollow cylinder. Okay. Next, third one, we will see what is the formula we use to find volume of the hollow cylinder. Okay. Volume. Its volume is given by pi H into R square minus R square. Okay. Capital letter R. First we will use external radius. A square of the the external radius minus square of the internal radius. Okay, see students, here capital letter R means external radius, small letter r means internal radius, and h means height. Okay, so this is height. Okay, this is nothing but h, height of the hollow cylinder. Okay, and pi means 22/7. Okay, you just remember this because in the next problem we'll use this hollow cylinder concept. Okay, so therefore I am explaining this. You just remember this. Okay, this is a hollow cylinder. Okay, and right circular cylinder you have already studied. What is the CSA of the cylinder? CSA 2 pi RH, TSA 2 pi r into r plus h, volume pi r square h. That is for a right circular cylinder. That is already you studied in the previous session. But this is another type of cylinder, that is a hollow cylinder. Okay, hollow cylinder means suddenly you have to remember here it will be having two type of radius, internal radius and external radius. Okay, you just remember this. We'll see the next question. Fourth question. A well of diameter, a well of diameter 3 meter is dug. 3 meter is dug 40 meter deep. The earth taken out has been spread. It has been spread evenly all around it in the shape of a circular ring, in the shape of a circular ring. In the shape of a circular ring of width 4 meter to form an embankment, Find the height of the embankment. Find the height of the embankment. Find the height of the embankment. Okay, so this is your question. Okay, yes, so we'll see the question now. Okay, yes, see here given a well of diameter 3 meter is dug 40 meter deep. Okay, yes, so also given the earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meter to form an embankment. This is the given information, isn't it? Okay, so first I will draw the figure. Okay, yes. See, first I will consider well. Okay, this is well. See students, well means obviously it will be in a cylindrical shape, isn't it? Well means it is in cylindrical shape. Okay, yes. See, also they have given one embankment. Okay, see, suppose is the embankment I will consider. Okay. See here. This is the well. Okay. So for the well deep, what is the depth of that well? That is 40 meter given. So therefore, from here to here, this is the deep. Deep is nothing but height. Okay. Height of this cylinder. Okay. I will represent it by capital letter H. What is that? 40 meter given, and also given the diameter of this well. Okay. What is the diameter? Diameter is about 3 meter. Okay. If suppose this is O, I will represent, and sorry, this is O dash, I will write, this is O. Okay. This point I will represent it by O. Okay. So what is the diameter? Diameter is given 3 meter. Diameter is equal to 3 meter. Okay. Yes. Then what about the radius? Radius will be the half of the diameter, isn't it? So therefore, what is the half of 3 meter? Half of the 3 meter is given by 1.5. 3 by 2 equal to how much? 1.5, isn't it? Okay, so I'll solve it later. Okay, next also given. Okay, so the earth taken out of it, the earth taken out from this well has been spread evenly all around it in the shape of a circular ring. Okay, so you can observe here circular ring of width 4 meter given. Okay, that means this is the width. Okay, from here to here it indicates width. I represent it by AB. Okay, so what is the length of AB given here? AB will represent width of this circular ring. Okay, so what is the width given? Width is equal to 4 meter. Okay, so this is nothing but width. Okay, this is nothing but width. Okay, this 4 meter will indicate width of the circular ring. Okay, yes. To form an embankment, find the height of the embankment. Okay, if suppose this is the height of the embankment, so your question, what is the height of this embankment? This is your question. Okay, yes. Okay, see here. So solution. So first, I'll consider well. Okay, this is the well. A well is in which shape? Cylindrical shape. So therefore, first I'll consider cylinder. Okay, cylinder means this is well. Okay, yes. Next, okay. Next, another one. What is this? Embankment. Okay, embankment. See, students, embankment means, can you remember a hollow cylindrical shape? Yes, hollow cylinder. Yes, so this is embankment will be in which shape? Hollow cylindrical shape. Since it is a circular ring given, okay, so therefore this embankment will be in which shape? Hollow cylindrical shape. Okay, next, hollow cylinder. Here, hollow cylinder is nothing but embankment. Okay, is nothing but embankment. Okay, so now we'll write the data which they have given here. Okay, yes. For the cylinder, what are the informations given here? For the cylinder, they have given the height given. Okay, what about height? 14 meter. I'll represent it by capital letter H. So height is equal to 14 meter given, and also diameter of this well given. What about the diameter? Diameter is equal to 3 meter. So therefore D is equal to 3 meter. So therefore what about radius? Radius is equal to 3 by 2. So 3 by 2 means 1.5 meter. Okay. So therefore, okay, I will represent it by O dash. A dash. O dash A dash will be equal to how much? 1.5 meter. Okay, 1.5 meter. Okay, so if O dash A dash is 1.5 meter, then what about OA? OA is is also equal to 1.5 meter. Understood now? O dash A dash is nothing but a radius. Okay, this is equal to how much? 1.5 meter. So therefore, what about OA? OA is also 1.5. So OA is also equal to 1.5 meter. Okay. So now we will come to the hollow cylinder. Okay. Hollow cylinder means embankment. Okay. See students, for the hollow cylinder means suddenly you have to remember you will be having two type of radius, that is internal radius and external radius. Okay. So first we will write the internal radius. Okay. Okay. See students, I will represent this radius of the cylinder by R1. Okay. So here R1 will indicate radius. Okay. Or else you can see R also. Okay. No problem. Small letter R. Okay. No problem. Small letter R. Okay. Yes. Okay. So first I will write the hollow cylinder. Informations for the hollow cylinder. Okay. See, for the hollow cylinder you will be having two type of radius. Internal radius. First we will see the internal radius. Okay. Internal radius. Okay. Yes. So in this figure, which is the internal radius? See, this is the circular ring here. So your internal radius is nothing but OA. The length of OA will represent internal radius. Okay. So internal radius is nothing but OA and represented by small letter r equal to how much? 1.5 meter. Okay. So why I represent why I use the same letter? Because the radius of the cylinder is also 1.5 meter. Again the internal radius is also equal to 1.5 meter. So therefore I will use the same symbol r only. Okay. Yes. So next again one more radius, that is external radius. External radius of this hollow cylinder. Okay. External radius. Okay. External radius. So which is your external radius here in this figure? Okay. External radius means O to B. The length of OB is known as external radius. Okay. The full length OB is external radius. OA is internal radius. Okay. So then OB. Okay. External radius is nothing but OB. Okay. I will represent it by capital letter R. Okay. I will represent it by capital letter R. Then what is the length of OB? See students, OB equal to OA. OA is about 1.5. What about AB? AB length given, that is 4 meter, isn't it? So therefore now can you calculate the OB length? OB equal to how much? OB equal to 1.5 plus 4. Okay. 1.5 plus 4 equal to how much? 5.5 meter. Okay. 5.5 meter. Okay. So therefore, what is the external radius? External radius is given by 5.5 meter. 1.5 plus 4. Okay. What is this 4? Width of the width given already. Is it written? Width of the ring, that is 4 meter. Next 1.5 is internal radius. How to get this 1.5? Because the radius of the cylinder, this is 1.5. So therefore OA is also 1.5. Okay. Yes. So therefore internal radius and external radius values are found. Okay. So now what you have to find? Your question is to calculate what is the height of this embankment. That means h is equal to question mark. H is equal to question mark. Height of the embankment. Okay. Yes. See students, according to this question, you can say that the volume of the earth taken out from this well will be equal to the volume of this embankment, isn't it? Volume of this embankment. Okay. Volume of the earth taken out from the well equal to volume of this embankment. Okay. Yes, I will use that concept here. Volume of earth taken out. Volume of earth taken out will be equal to volume of embankment. Volume of embankment. Okay. Yes. But here a volume of earth taken out from which one? From the well, isn't it? But a well is in which shape? Cylinder. So therefore, in the place of volume of earth taken out, shall I replace it by volume of cylinder? Yes, this is nothing but volume of cylinder, because the earth is taken out from well, but the well is in cylindrical shape. So therefore, volume of earth taken out is nothing but volume of cylinder. Okay, equal to volume of embankment. See students, embankment is nothing but a hollow cylinder, isn't it? Embankment is nothing but a hollow cylinder. So therefore, in the place of volume of embankment, I will replace it by volume of hollow cylinder. Okay, volume of hollow cylinder. Volume of hollow cylinder. Okay, so now write the formulas. What is the volume of the cylinder formula? Volume of the cylinder is given by pi r square h. Why I use capital letter H? Because the height of the cylinder is represented by capital letter H. Okay, equal to volume of the hollow cylinder. Just recall the formula. What is the formula? Volume of the hollow cylinder is given by pi h r square minus r square. Capital letter R square minus small letter r square. Okay. So shall I cancel this pi and pi? Pi and pi will get cancelled, isn't it? Okay. R square. What is the value of small letter r here? Small letter r. Okay. That is nothing but radius of the cylinder. What is the radius of the cylinder? 1.5. So 1.5 whole square into height. What is the height here? H is equal to how much? 14, isn't it? Okay. Equal to next. Okay. Okay. H value don't know. Write it as it is. Capital letter R square. What is the value of capital letter R here? Capital letter R means external radius will be equal to 5.5. So 5.5 whole square minus small letter r square means internal radius. Internal radius how much? 1.5. So 1.5 whole square. 1.5 whole square. Okay. Yes. So now first calculate what is the value of 1.5 whole square. Okay. 1.5 whole square is nothing but 1.5 into 1.5. Okay. We'll simplify. 5 5s are 25. 2 carry. 5 1s are 5. 5 plus 2 equal to how much? 7 into 1 into 5 5. 1 into 1 1 5. 7 plus 5 equal to how much? 12. Okay. 1 carrying 2. So what is the answer? 2.25 I will get. Okay. 2.25. Okay. 2.25 into 14. Write as this. So h into what is the value of 5.5 whole square? Okay. So 5.5 whole square is nothing but 5.5 into 5.5. Okay. Yes. So we'll simplify it first. 5 5s are 25. 2 carry. 5 5s are 25. 25 plus 2 how much? 27. Okay. Once again 5 5s are 25. 2 carry. 5 5s are 25. 25 plus 2 how much? 27. Okay. So we'll simplify. 5 7 plus 5 12. Okay. 7 8 9 10. 1 carry. So that we will get 30.25. Okay. 30.25. Okay. 30.25 minus 1.5 whole square. Already we have calculated. What is the value of 1.5 whole square? 2.25. Okay. 2.25. Okay. Yes. So we'll simplify it further. 2.25 I'll write as it is into 14 equal to h into, okay, 30.25 minus 2.25 equal to how much? 30.25 minus 2.25 equal to 28. I'll get 28. Okay. Yes. So now h value. So therefore h is equal to, actually we are going to calculate the value of h. So therefore h is equal to, first I will write the left hand side down. What is that? 2.25 into 14 by, write this 28. Okay. Yes. So now 14 and 28. Okay. So can I calculate? Can I cancel it by this 7? Yes. So 7 2s are 14. 7 how much are 28? 7 4s are 28. Again 2 1s are 2, 2 2s are 4. Right? So therefore I will get 2.25 by 2. Okay? Yes. So therefore divide 2.25 by 2. Okay? I divide it 2.25 by 2. 2.25 by 2. Okay? We'll simplify. 2 ones are 2. Okay? 2 minus 2 0. So next number 2. Again point. 2 ones are 2. 2 minus 2 0. Next term 5. 2 2s are 4. 5 minus 4 1. So take 1 0. So 2 5s are 10. So therefore what is the answer? 1.125. Okay. So this is equal to 1.125. Okay. So therefore the height of the embankment, okay, height of the embankment is given by 1.125. Okay. So h is equal to 1.125. What is the unit? Unit meter. Okay. See students, unit is important. Suppose if you are not written unit, they will deduct half marks. Okay, half marks will deduct. So therefore it's very important to write the unit. Okay. So what is the answer? 1.125 meter is the height of the embankment. Here embankment means a hollow cylinder. We'll see the next question, fifth one. A container shaped like a right circular cylinder, like a right circular cylinder, a right circular cylinder having diameter having diameter 12 centimeter and height 15 centimeter is full of ice cream is full of ice cream. The ice cream is to be filled. The ice cream is to be filled the ice cream is to be filled into cones of height 12 centimeter and centimeter, having a hemispherical shape, having a hemispherical shape, a hemispherical shape, a hemispherical shape on the top, on the top. Find the number of such cones. Find the number of such cones. Find the number of such cones which can be filled with, which can be filled with ice cream. Okay, which can be filled with the ice cream. Okay, this is your question. Okay, yes. A container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. Okay, so here solution. So first, a container is a shape of which one? Right circular cylinder. Okay, so first I will consider right circular cylinder. This is a right circular cylinder. Okay, so this right circular is full of ice cream. Okay, so this container contains full of ice cream. Okay, having diameter 12 centimeter. Okay, so this is cylinder. So for the cylinder, what are the informations given here? Okay, for the cylinder, diameter given. Diameter is equal to 12 centimeter. So therefore, what about radius? Half of the diameter. Okay, what is the half of this 12 centimeter? That is 6 centimeter, isn't it? So therefore, radius is equal to 6 centimeter. Height 15 centimeter. Okay, so the height of this container is 15 centimeter. Okay, so therefore h is equal to 15 centimeter. Okay, yes. Now the ice cream is to be filled into the cone of height 12 centimeter. Okay, so what I will do? Okay, next what I will do? I will fill this ice cream and fill this ice cream into the cone. Okay, I will fill this ice cream into the cone. Okay, what is the height of this cone given? The height of this cone is what about 12 centimeter. Okay. So for the cone, next for the cone, okay, what are the informations given for the cone? Height given. Okay, so I will represent it by, okay, so for the height of the cylinder I will represent it by capital letter H. Okay, so height of the cone I will represent it by small letter h. What is the height given? Height is equal to 12 centimeter. Height is equal to 12 centimeter and diameter is equal to 6 centimeter. The diameter of this cone is equal to how much? 6 centimeter. So therefore, diameter is equal to 6 centimeter. So therefore, what about radius? Half of the diameter is equal to 3 centimeter. Okay, yes. So students, I will represent the radius of the cylinder by capital letter R. Okay, capital letter R, because radius of the cylinder is larger than radius of the cone, isn't it? Radius of the cylinder is 6 centimeters. This is larger, so therefore I use capital letter R. And for the cone, I use small letter R. Okay, yes. This is for the cone. Okay. Also given having a hemispherical shape on the top. Okay. So on the top you will be having one hemispherical shape. Okay. So one more shape you can observe here. What is that? Hemisphere, isn't it? Okay. So one more shape, that is a hemisphere. Okay. So for the hemisphere, okay, what is the radius? Okay. We know that radius of this cone is equal to radius of the hemisphere. So therefore, I use the same value. R is equal to 3 centimeter. Okay. So here also small letter r. Here also small of the hemisphere, that is about 3 centimeter. Okay. Find the number of such holes which can be filled with the ice cream. Okay. So what is the number of such type of ice cream cone? Okay. So suppose I consider, let n be the number of cone I consider. Okay. Let n be the capital letter N I use. Let capital letter N be the number of ice cream cone I consider. Let n be the number of ice cream cone. Okay. N be the number of ice cream cone I consider. Okay. So therefore here, see here, initially the ice cream was contained in one cylindrical container. Later I will shift this ice cream to the cone with hemispherical. Okay. So how many such cones? So there are n number of cones. Isn't it? There are n number of such cones. Okay. So therefore actually your question is to find n value. What is the number of cone you have to find? Okay. Yes. So therefore, shall I write here volume of this cylinder? Volume of cylinder equal to volume of cylinder equal to, okay, how many cones are there? There are n number of cones, isn't it? So n into, okay, so this is a combination of cone plus hemisphere. So n into volume of cone, plus volume of hemisphere, volume of cone plus volume of hemisphere. This is your question. Understood now? Okay. See, volume of this cylinder is equal to n into volume of this cone plus hemisphere. So volume of cone plus volume of hemisphere. Okay. Yes. What is the formula for a volume of a cylinder? Volume of a cylinder is given by pi r square h. Pi r square h. Okay. So why I will use here capital letter R? Because the radius of the cylinder is capital letter R and the height of the cylinder is capital letter H. Okay. Yes. So next equal to n into, what is the formula for volume of a cone? Volume of a cone is given by 1/3 into pi r square h, isn't it? Plus, what is the volume of the hemisphere? Volume of a hemisphere is given by 2/3 into pi r cube. 2/3 into pi r cube. Okay. Yes. So now pi r square. What is the value of capital letter R? Capital letter R is equal to 6. So therefore I will write 6 square into h. What is the value of capital letter H? Capital letter H is equal to 15. Okay. Yes. Equal to n into. Okay. So first of all, take the common term. Okay. What is the common term here? The common term is given by. Okay. So can you observe here pi r square is a common term. Shall I take it outside? Okay. So n into pi r square is the common term. So now write the remaining term. What about the remaining term? 1/3 into h plus 2/3 into, from this r cube, r square outside, so one more r remain here, right? Okay. So now shall I cancel this pi and pi? Yes. Okay. So 6 square equal to 36. So 36 into 15 equal to n into, what is the value of small letter r? Small letter r is equal to how much? 3. Okay. So small letter r square means 3 square. Okay. 1/3 as it is h. What is the value of small letter h? Small letter h is equal to 12 plus 2/3 as it is into small letter r. What is the value of small letter r? Small letter r is equal to 3. Okay. Yes. So now shall I cancel this 3 and 3? Yes. Okay. So again 3 ones ones are 3, 3 fours are 12, right? Okay. So 36 into 15 I'll write as it is equal to n into 3 square equal to 9 into 4 plus 2. 4 plus 2 will remain inside the bracket, isn't it? 4 plus 2 will remain. Okay. Yes. So next term 36 into 15 I'll write as it is n into 9 into 4 plus 2 equal to how much? 6. Okay. So now I am going to calculate the value of n. Okay. So therefore n equal to, first I will write the right hand side term, that is 36 into 15 by, what about the denominator number? 9 into 6. 9 into 6. Okay. We'll simplify now. See, 6 ones are 6, 6 six are 36. Isn't it? Next, 3 threes are 9, 3 twos are 6. Right? Once again, 3 ones are 3, 3 fives are 15. Right? So therefore, what is the value of n? N is equal to, what is the remaining number? 2 into 5. So what is the value? 2 into 5 is given by 10. Okay. So therefore, what is the number of ice cream cone? The number of such type of cone is given by 10. Okay. So this is the answer. Very important question this is. Okay. So what is the exact number of ice cream cone is given by 10?
We'll see the next question. Sixth question. How many silver coins silver coins 1.75 centimeter in diameter and of thickness and of thickness 2 millimeter must be melted to form a cuboid of dimensions 5.5 centimeter into 10 centimeter into 3.5 centimeter. This is the question. Okay. Yes, actually in the question given here, okay, how many silver coins? Okay, so silver coin given. Okay, so first of all I'll draw the figure. Okay, silver coin. Okay, suppose this is the silver coin. Okay, if suppose this is the silver coin. Okay, 1.75 centimeter in diameter. Okay, so silver coin means it will be in which shape? Cylindrical shape. Okay, yes. So therefore I'll consider this cylinder. Okay, cylinder. Okay, so first I'll write the cylinder means here silver coin. So first I'll write the informations regarding to the silver coin. Okay, diameter given, diameter is equal to how much? 1.75 centimeter. 1.75 centimeter. This is the diameter. So then what about radius? Radius will be the half of this diameter, means 1.75 by 2. Okay, see students, this is in decimal form, isn't it? 1.75 is in decimal form, okay. So if it is decimal form means it may difficult to multiply or calculation. So therefore, first of all, 1.75, okay. So here after the decimal point you have two decimal numbers. So therefore I'll multiply and divide by 100, okay. Yes. So this is equal to 1.75 into 100 equal to how much? 175 by 2 into 100 is equal to 200, okay. So 25 sevens are 25 eights are. So therefore this is equal to how much? 7 by 8, okay. So therefore what about the radius? Radius is equal to 7 by 8 centimeter, okay. Yes. Also given thickness is equal to 2 millimeter, okay. See, this is the thickness is about 2 millimeter, okay. But students, thickness is nothing but a height of this cylinder, okay. Yes. So also given thickness, okay. Thickness is equal to how much? Thickness is nothing but height equal to how much? 2 millimeter given, okay. Thickness is equal to 2 millimeter, okay. Yes. See students, here all the informations are given in terms of centimeter, isn't it? See, this is a dimension of a cuboid. This is also in the shape of this is also in the form of centimeter. Also diameter is also given in terms of centimeter, but only thickness is given in terms of millimeter, isn't it? So first I'll convert this millimeter to centimeter because remaining all terms are given in terms of centimeter. So therefore, I'll convert this millimeter to centimeter. How to convert? What is the relationship between a centimeter and a millimeter? See students, we know that 1 centimeter is equal to 10 millimeter. Understood now? This is a relation, very important. Remember, 1 centimeter is equal to 10 millimeter. So therefore 2 millimeter equal to how much centimeter? What we have to do? Cross multiplication. 2 into 1, 2 itself by 10. Okay, this is equal to 2 by 10 centimeter. Okay, so therefore 2 millimeter is equal to 2 by 10 centimeter. Okay, so therefore 2 millimeter is equal to 2 by 10 centimeter. Okay, 2 ones are 2, 2 fives are 10. So this is equal to 1.5 centimeter. So therefore, what is the height of this? What is the height of the cylinder? That is about 1 by 5 centimeter. Okay, yes. So next another shape, what they have given here, okay, is melted. Okay, is melted. Okay, we will melt it. Okay, we'll melt it to form a cuboid. Okay, so we'll convert it in the form of cuboid. This is the cuboid. Okay, yes. So what are the informations are given for cuboid? This is the cuboid. Okay, this is a silver coin and this is a cuboid. Okay, see, they have given the dimension of the cuboid. Okay, dimension of the cuboid is nothing but length, breadth, height. Okay, so therefore for the cuboid, what are the informations given here? For cuboid, what are the informations given? Length given. Length is equal to how much? 5.5 centimeter. This is about 5.5 centimeter. Also breadth given. What is the value of breadth here? Breadth is equal to 10 centimeter. Breadth is equal to 10 centimeter. Also height given. Height is equal to 3.5 centimeter. But see students, we have the height for cylinder also, isn't it? So therefore, shall I represent it by capital letter H? Because height of the cylinder and the height of the cuboid both are different. What about the height of the cuboid? 3.5, but height of the cylinder is about 1 by 5. So both are different. So therefore, I'll use different symbol. Okay, yes, yes. So now you have to find how many silver coins. Okay, so therefore you have to find the number of silver coins. Okay, what is the number of silver coins that has to be melted? Okay, so I'll consider let n be the capital letter N be the number of silver coins melted. Let n be the number of silver coins melted, I will consider. Okay. So now see here, according to this question, if I melt n number of silver coins, okay, I'll melt it to the form of a cuboid. Okay. So therefore we can say n into volume of one silver coin is equal to volume of a cuboid. Okay. N into volume of one silver coin. So therefore volume of n into volume of, because there are n number of silver coins. So therefore n into volume of one silver coin, n into volume of one silver coin is equal to volume of cuboid. Okay. So now n I'll write as it is. What is the formula for one volume of the silver coin? Silver coin will be in which shape? Cylinder shape. So therefore, shall I replace volume of one silver coin is nothing but volume of one cylinder, because one single silver coin will be in which shape? Cylindrical shape, equal to volume of cuboid. What is the formula? LBH. The formula is LBH. Okay. Yes. So n into, what is the formula for volume of the cylinder? Volume of the cylinder is given by pi r square h. Okay. Pi r square, I'll use capital letter H because height of the cylinder is capital letter H here. This is equal to L into B into H. Okay. We'll substitute the value now. Okay. N I'll write as it is. Pi value is 22 by 7 into r square. What is the value of r here? R is equal to 7 by 8. So therefore r square is given by 7 by 8 whole square into height. What is the value of capital letter H? Height is equal to 1 by 5 equal to L into B. What is the value of L? 5.5 into B value 10 into H value 3.5. Okay. Yes. So now n into 22 by 7. Okay. 7 by 8 whole square. Shall I split it as 7 by 8 into 7 by 8? Okay. So therefore I'll split it as 7 by 8 into 7 by 8 into 1 by 5, write as it is. 1 by 5 equal to 5.5 into 10 equal to how much? 55. So 55 into 3.5. 55 into 3.5. Okay. Yes. So now shall I cancel this 7 and 7? Yes. Okay. Next, once again. 2 4s are 8, 2 11s are 22, isn't it? So therefore I'll write the remaining term n into 11 into 7 by denominator 4 into 8 into 4 into 8 into 5 equal to 55 into 3.5. 55 into 3.5. Okay. Yes. Now this is your denominator term. Shall I multiply this denominator term with 55 into 3.5? This denominator term will multiply with this term, isn't it? Okay. So now we'll simplify. Okay. First I'll write the numerator. What about the numerator? N into 11 into 7 equal to what about this? 55 into 3.5 into while this term will comes here 4 into 8 into 5. Okay, 4 into 8 into 5, 4 into 8 into 5. Okay, yes. So now we'll simplify. N into 11 into 7 equal to how much? 77 equal to 55 into 3.5 into 4 8s are how much? 32 into 5. Okay, yes. Okay, students, now actually we are going to calculate the value of n. Okay, so therefore n is equal to, first I'll write the right hand side term 55 into 3.5 into 32 into 5 by 77. Okay, yes. See, 11 7s are 77, 11 5s are 55, isn't it? Okay, so once again 7 1s are 7, so 7 how much are 35, 7 0.5s are 35, sorry 7 0.5s are 3.5, yes, correct, no? 7 1s are 7, 7 how much are 3.5, 7 0.5s are 3.5, isn't it? Okay, so now, so n is equal to, what about the remaining term here? The remaining terms are 5 into 0.5 into 32 into 5, right? Okay, so now n is equal to, okay, we'll simplify this. First I'll multiply 5 into 5. 5 5s are how much? 25. So 25 into 0.5 into 32. Okay, so multiply those terms. Okay, I'll multiply here. So n is equal to, okay, 25. First number 25. 25 into 0.5 into 32. Okay. So first I'll multiply 25 into 32. Okay. 25 into 32 equal to how much? 32 into 25. We'll multiply 5 2s are 10, 1 carrying. 5 3s are 15, 15 plus 1, 16, 2 2s are 4, 2 3s are 6. So 6 plus 4, 10, 6, 7, 8. So that I'll get 800, isn't it? Okay. So therefore n is equal to 800 into 0.5. Okay. Yes. So 800 into 0.5. First I'll write 2 zeros as it is. So 8 into 0.5 equal to how much? Okay. So 5 8s are 40. 4 carrying. 0 into 8, 0. 0 plus 4 how much? 0 plus 4, 4. So therefore you will get 400. Okay. So therefore what is the number of silver coins are melted? That is equal to 400. Okay. So the exact number of silver coins is equal to 400.